Okay, so let's give you guys some practice. So here, differentiate this. Find dy by dx of this here. Okay, so if you get a graph plotter and plot this here, it will give you this red graph here. So your derivative should be, looking at this, your derivative should be negative, 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 negative. So it should be somewhere in this region here. And then past this bit here, it should be positive, 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 positive. So your derivative must be in the positive realm somewhere up here. Okay, so well, anyway, find dy by dx of this here. So press pause and have a go. Okay, so to do this here, hang on, sorry, hang on. So to do this here, um, yeah. So to do this here, visualize it as this. So you've got this bubble here on top, and then this bubble here at the bottom. So you can actually do. At the moment, you've got this. That equals natural log of a minus natural log of b. So so you can visualize it as log of the top part, which is this bit here. Take away log of the bottom part, and visualize the square root as being to the power of a half. Okay, and then now you can move the 2 out here, because whenever you have log of something to the power, then you can take the 2 out. Well, that will then give you this, and then same thing here, move this 2 out here, that will then give you this, and then what? Hang on, and then now differentiate. So take the 2 down, and then imagine this as a bubble here. So when you differentiate this, it will be 1 over the bubble here. But because within the bubble here, you've got to differentiate the bubble itself, which will give you this. Okay, so if you differentiate this, it will give you this. Okay, and then differentiate this, the half here, and then differentiate this, it will be 1 over this thing here. And then you've got to times with the differential of the bubble itself. When you differentiate the bubble itself, it will give you minus 1. So that will give you this minus 1 here. So now tidy up. It will give you this. So get a graph plotter, plot the 2 graphs. So the red line here represents our original y equals blah blah blah. The blue line here, I don't know if you can see, the blue line here represents our derivative. The blue line here represents this. Okay, so looking at this, double check everything. So looking at the red line here, the derivative should be negative, 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 and really, really big negative, negative. Now looking at the blue line, it is indeed in the negative realm here. Okay. Now looking back at the red line here, it's positive, 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 positive. So looking at the blue line, it's still in the positive realm here. Positive, positive, positive. It's still in the positive realm. Okay. And by the way, over here, it's beyond our domain here, because if you look at the original graph, if you look at the original this here was our original thing here. Now remember, at the moment, if you look at this, at the moment, you've got log of whatever here. Make sure the whatever here is beyond. Make sure the whatever here is beyond the negative. Okay, so this thing here has to be beyond the negative. And looking at this thing here, make sure, because you've got a square root here, make sure this bubble here is make sure this bubble here is positive. Okay, and the only time it can stay positive is if you make this well, if you put, let's say if you put a number 9 in here, it would be negative. If you make x 9, let's just say 9. Well, the point is that looking at this here, you can see that the domain. Hang on, looking at the graph here, you can see that this here is beyond it's not in our domain here, so we can pretty much forget about this side of the graph. It makes sense. It makes sense when it's in the negative realm here. Okay.